my name is Kellyanne Mahoney. I manage education audiences for Autodesk, and I'm super excited to be here with our friends from ACE. We have an exciting agenda for today, and again, we're going to be talking about the Make It Home contest, and we're going to be doing this in collaboration with the ACE Mentor Program. If you're not an ACE student, we just want to say welcome to you. We're glad that we have opened this up to students beyond the ACE community. We always love to have students from the ACE community, and maybe you can become part of it after this webinar as well if you're not already. So we do have goals for this webinar. We're going to be talking about some really cool trends in emerging technology and in industry to help you think about what you want to do, what your future is going to be. We also want to talk to you more specifically about the construction industry and how people in the construction industry are harnessing these new technologies in order to make a better world. So using green skills, thinking about environmental sustainability. So we have a lot in store for you to kind of think about that and maybe even apply it to your contest entry. Most importantly, we want you to discover resources that will enable you to build your tech skills, challenge yourself, explore careers, and also find funding to continue your learning. You will be guided through this journey with our wonderful co-host Paulette, who's been multitasking, letting everyone in, and also checking the chat as well. So Paulette is the National Director of Partnerships from the ACE Mentor Program. So you'll hear her voice throughout just to make sure that this is not just a one-way conversation, that we have room for your questions and, for you to just kind of share what you're thinking as the presentations are happening. So thank you, Paulette, for doing that. Paulette, did you just want to say a quick hi to the group?
Yes. Hi, everybody. We're so excited that you're here. I can't wait to see what your projects become. Thank you, Kellyanne.
Thank you, Paulette. So we have a packed agenda. So we're going to begin actually with Jack, who is the South Regional Director for the ACE Mentor Program. And he's just going to share with the audience a little bit about what is ACE, how you can join. And Jack has also in the past been a mentor for students in his past life before he joined ACE to help them with their entries to this contest. So we might hear a little bit from him about that too. Next, I'm going to jump in. I'm going to share with you some more detailed information about the contest and also do a little technology demonstration for you to just help you think about how you might get started if you haven't yet already. We also are going to be joined by my colleague at Autodesk, Dr. Fope Badamosi. She is a construction researcher, and she's going to talk a little bit about these emerging trends in technology. She's on our research team, so she's really kind of on the cutting edge of what the future might look like for construction and particularly affordable housing, which is the theme of the contest this year. And last but not least, we are so excited to welcome Michael Hidalgo, who is an Autodesk Design and Make Ambassador. He's also a judge for this current contest, as is Fope. But Michael is also a past winner. So he was an ACE Mentor student in Miami who entered this contest in 2022 and won. So he has lots of insight to share. So thank you, Michael, for joining us. So I'm going to pass the mic now to Jack, who's going to talk a little bit about what is ACE and how can I join.
Yes, thank you, Kellyanne. All right, hello. My name is Jack Whalen. I am the South Regional Director for the ACE Mentor Program of America. I am a licensed architect, and I'm also proudly an ACE alumni. ACE, originally founded in New York City in 1994, launched with the goal of connecting high school students to the AEC fields to teach them about the many amazing career paths in our industry. Bringing industry professionals into the high school classroom, the ACE Mentor Program engages, excites, and enlightens high school students to help them grow into leaders and make informed career decisions towards their post-secondary education and training. You keep going. Thank you. Since 1994, ACE has grown into a national program for students across the country with various opportunities for students, including mentorship, scholarships, seasonal projects, summer experiences, and competitions, with incredible industry partnerships such as Autodesk and the Make It Real program. Keep going. Thank you. Looking at ACE by the numbers across the country, ACE is in 38 states and over 200 cities. Amongst our over 75 affiliate locations, ACE is involved in over 1,500 schools, has over 14,000 students, and over 5,000 mentors. In total, ACE has awarded over $37 million in scholarships to the next generation of AEC professionals, with $4.5 million being awarded in the last year alone. In total, ACE has awarded It is also important to note that the time our mentors contribute to the program is on a volunteer basis. Last year, their time donated was worth over an estimated $20 million, a testament to their commitment to the next generation.
Wow.
Yeah. And if you are interested in getting involved in ACE or have any questions, you can reach out to your local ACE contact by using the Find a Program tool on our website homepage, or by reaching out to your regional director below, including myself. Lastly, make sure to follow us on social media to stay up to date with ACE, learn about national opportunities, scholarships, and more by scanning the QR code on the screen.
So cool, Jack. When I think about even just looking at this map and just the network of, like, I didn't know you were an ACE alum yourself, and just kind
Yep.
of this like national network of these young innovators that are then entering, you became an architect yourself. So that's so cool.
Yeah, we really try to pass the torch here within ACE to the next generation. And we hope if you partake in the program that you'll consider getting involved as well once you graduate. But as Kellyanne said, I have been a mentor in the program and worked with students in this amazing contest. And if we have some mentors on the call as well, just a few little tips of advice for anyone trying to look to facilitate this amazing contest locally. So in going through this contest, consider putting together a meeting schedule, right? So it could help, keep you on track towards the project deadline, which is great. It also gets a little bit into project management, right? Like going from the deadline, how can we backtrack from that to accomplish our goals? Developing encouraging students to share feedback with each other as well, right? This could be a collaborative experience. We're stronger together in all of our different projects. So make sure that this is a learning pot, right? And make sure to help each other through this process. And just lastly, as well, running students through the submission steps is extremely helpful, right? Don't wait till the last minute to open up an account and see what you need, right? You should be planning from the beginning so that you know what to do and that it's not last minute. So with that, thank you so much. And I wish all of you the best of luck in the contest, and I'll pass it over.
Thank you so much, Jack. That was great. And I hope that we get more students to join ACE as a result of this webinar. So if there are any questions, are there any questions in the chat so far, Paulette?
Nope, not yet.
All right, well, do please, just in thinking about how to participate, if you have questions, and I'm going to be presenting for a little bit in a minute, Paulette, please, feel free to jump in and interrupt if it's an urgent question.
Okay, no problem. Thank you.
All right, so I'm going to start by talking a little bit about tips and inspiration for getting started. And I'll maybe even explain this cool GIF that you keep seeing in the presentation and where it comes from. But to begin, just to introduce you to Autodesk, if you haven't been introduced before, we're a software company. We make software for people who make things. We're a global company, and we're guided by this belief that we can build a better world together that's designed and made for all. And we are so inspired by our customers who do that every day. So what sort of things do they make? So with Autodesk software, it's categorized kind of in 3 different buckets of things that you can make. You could design bridges, buildings, infrastructure, so things for the AEC and construction industry. You could design consumer products or cars or furniture, for example, or even building components that need to be manufactured or prefabricated. You could also design and make graphics for video games, for animations, for films. So there's all types of things that students can design and make with our software that's kind of leading them on a path to careers that our customers do in real life. One thing to kind of think about in terms of, these are kind of 3 different ways of designing and making things, but the connective thread that brings it all together is that our technology kind of bridges the gap between design and make. So to think about it within the context of the building industry, we might think of the different phases of a construction project life cycle. So from design to plan to build to operate. Our customers who are using our software are able to kind of have a common data environment where they can pass along different tasks and even work asynchronously across this life cycle. And thinking about phases. So we also like to think about phases in the context of our young people who are being introduced to our software. So one of the first tools that Autodesk makes that you might be introduced to or you might have been introduced to in the past is Tinkercad. So Tinkercad is a free web app for 3D design, electronics, and coding. It is, geared towards those who are just getting started with 3D design, but it's okay if you're in high school and you're just getting started, or if you even know how to use some of our more sophisticated or more professional tools like Revit. You might still want to, for your concept, you might want to think of Tinkercad as like a digital sketchbook that you could use to just kind of flesh out some concepts really quickly and easily. So you can think architecturally In Tinkercad, you could design a house, for example. You could design a dream room. There's also a code blocks environment within Tinkercad, so you can play around with, this idea of computational design. You might think about how you might move between the different environments in Tinkercad. So maybe you're making a set of stairs using the code blocks environment, and then bringing it into your 3D editor in order to add it to the house that you're designing. And as you're building these skills, you might apply them to then more professional tools like something like Forma or something like Revit, where you can, bring those skills and kind of take them to the next level. So you might explore things like computational design in our more professional architecture tools. So in Tinkercad, you might do something like design a bridge. You could even do that computationally as well using the code blocks environment. You might then take that bridge into the 3D editor and kind of build some more real world context around it. You might use the code blocks environment to think about like a street grid or to like a plan for an urban neighborhood. And you might even add in like a random block and some variables in order to kind of play around with almost like a generative design concept. And then you might take that idea and bring it into a tool called Forma, which is one that I'm going to talk about with you today. And you might bring that neighborhood that you designed and run analysis on it in order to, find out the different levels of sunlight in the area, or the way the wind is going to hit the buildings, or the level of noise. You might be someone who likes to get hands-on. Maybe you're in a vocational program and you're also taking like carpentry or some of the building trades. And you could use Tinkercad to plan out the design of, maybe you have constraints around how much of materials that you have to make something like a bench or a table. So you could plan it out in Tinkercad. You could also play around with electronics and circuitry and do it in a way that's simulated, so you're not burning out parts in real life, you're doing it digitally. You could explore concepts like Ohm's law. You could also, within Tinkercad, play around. There's actually an HVAC set of blocks that you can play with in Tinkercad and think about HVAC design. And then you might want to move on to a more professional tool like Revit to really kind of get into and puzzle through, what HVAC design really is like in a real building. You might also use a tool like Navisworks, or even within ACC, you can do clash detection to think about, how are the electrical systems and the plumbing systems and the fireproofing systems in a building, how are they all kind of fitting together. Also, just like you might think about Tinkercad as like a play space where you can play with ideas and then, level them up from there. You might do something like design a playground in Tinkercad. You could even quantify the materials by playing around with the bricks environment. You might think about like safety as you're designing and thinking about measuring the different structures that you're creating. And then you might move into a more professional tool again, like Autodesk Construction Cloud, to think about, how are you managing your construction project? And also like really kind of getting into like quantity takeoff. This is actually a really cool visual. It's like a 3D takeoff that you can do within Autodesk Construction Cloud. So these are just kind of all the places that you can go using our professional tools in combination with Tinkercad. So this is where you would go to learn more about how you, your educators, your schools can access or unlock access to our professional tools for free. So you can see them all here. And if you could just Google Autodesk Education Tools, you'll find it. Any questions so far, Paulette?
Nope. Oh, wait, one just came up.
What is the question?
That's it. Nope, I can't. I'm not able to read it. It's in a different language for some reason. I'll have to translate that and get back to you.
Okay, we'll figure it out. That's why I love working with Ace. We figure things out.
Yes.
So the program that we're featuring is the Make It Real program. So this is kind of where you go to find out basic information about the program. One thing that I want you to know about the Make It Real program, of which the Make It Home contest is a part of it, is there's also an additional component, which is micro grants. So if you're a student ages 17 to 22, who is thinking about transitioning from high school into the building trades, we offer $500 micro grants to you. That's flexible funding. And you can find out more information about that on the Make It Real, Autodesk.com Make It Real webpage. On the page, you can also find this cool film series that we created with Josh Dobbs, who's NFL quarterback. He had been on the 49ers last season. Upcoming season, he's going to be on the New England Patriots. So we're super excited for Josh. One of the reasons why we have actually worked with Josh year over year in this campaign is he has an interesting background, not just as if it's not interesting enough to be an NFL quarterback. He also is an aerospace scholar. So he studied aerospace engineering when he was in college, and he interns with NASA in the off season. So he has this really cool and like rich background in engineering and kind of thinking about the future and systems and how they all kind of come together. And he's kind of drawn parallels between what he's learned at NASA and the kind of cool futuristic things that he's seeing when we bring him to these construction sites. And how, you know, a construction site is almost like starting to look like something you might see at NASA. So this year we brought him to Vallejo, California, outside of San Francisco, to this company called Factory OS. And Factory OS is on this cool island off the coast of California where they used to actually, it's called Mare Island, and they used to build submarines and ships for the Navy. Rosie the Riveter worked there as well. Now this space that used to be a place where they built ships and submarines, they're now reimagined it and repurposed it as a factory where affordable housing is built. So they make prefabricated modular housing that can come together on a construction site and look like a beautiful, like it wasn't prefabricated. So we are working with him. We brought him to Factory OS, and we kind of took him through the different phases and the different kind of jobs that people do at Factory OS, from designers to, fabrication workers to people who are painting, and really kind of bringing the whole project together. So I just want to give you a sneak peek of what that one of the films looks like. And you can find the rest of the films at autodesk.com/make-it-real.
I'm Joshua Dobbs, and I'm here today to shine a light on a problem close to home for many of us. Join me as we see how Autodesk is helping build the playbook in response to the housing crisis, making homes more affordable, more available, and more resilient.
At Autodesk, we provide software for people who design and make things. Architects, engineers, contractors. I think you're going to learn a lot through the tour you're going to get here today.
Check out autodesk.com/make-it-real for inspiration, learning, and scholarship opportunities.
So that's just a sneak peek with Josh.
I'm Joshua Dobbs.
You can find more at autodesk.com/make-it-real. And this little
Wait,
graph.
Kellyanne, I do have a question real quick.
Oh, awesome.
Yeah, how do you hydrate hand-drawn plans, like for exterior or site plans, into a program from a sketchbook? Are there plugins for AutoCAD and Revit?
So in order to bring hand drawings into like a program like AutoCAD, is the
Yeah.
Fope, is Fope here yet?
No, I haven't seen her. Nope.
Okay, so Fope will be joining in a minute, and let's remember that question before we introduce Fope. She would definitely be able to answer that better than I can.
Okay, perfect.
She works a lot in Revit. So just to share, but that was a great question. Just to share a little bit about that little graphic that we see in the lower corner, this is actually a graphic that is illustrating the design, the kind of modular design process that Factory OS uses in their work. So this is what the contest page looks like. So the contest page that you can find from the campaign page is hosted on Instructables. So Instructables is a platform that's also part of Autodesk. It's a community of people who are DIYers and people who like to make things, from chocolate chip cookies to rewiring an electric lamp to, designing like structures and buildings. So it's a place where you can enter contests. It's also a place where you can share your projects and kind of step by step to teach others how you did them. So that's where the contest is hosted, and you can find out more information about the different prize levels and the different ways, like the criteria of how we're judging the contest. We'll talk about a little bit here as well. So our prompt this year is, what if affordable housing could solve other problems in a community? And these are the different categories of top prizes. So we have a best CAD prize that's really kind of focused on the use of the tools. So you need to include some sort of an Autodesk tool as part of your workflow. So that's one of the prize categories. Another is physical prototype. We're a company that we are focused on designing and making. So we really wanted to place an emphasis on actually the constructability of your design and actually trying to physically make it. So we'll talk a little bit about that. We do have a team category this year as well, but the team category is strictly for students 18 and older who are connected to a community or technical college in some way. So I wanted to make that clear. So this is just an example. I thought that it might be inspirational to see designs from students from past years. So last year, our contest was called Make It Resilient. And the focus was designing habitats for extreme environments. The example, because we're working with Josh, the example that we used was space, but it could also be the desert, it could be the Arctic, it could be places with limited infrastructure. But one of the students who won last year for best CAD design was Rocky, and he designed this really cool habitat for space. So he used Fusion for his design, which you're welcome to use. And he also did some really cool stuff with Fusion in terms of the animation features within it. So this is just a sense of, what students have produced as the results of this challenge. So what I want you to think about as I present, so I'm going to share with you the students' project who won Best Physical Prototype last year, Ajith. As you're watching this kind of step-by-step process of how Ajith put his design together, I want you to start thinking about the rubric that we're using to judge. So it's broken down into 4 categories. So it's engineering mindset, real-world relevance, presentation, and 3D digital literacy and design. And to kind of explain this a little bit further, it's like engineering habits of mind, so like visualizing, creative problem solving. There's also kind of a storytelling component to it, thinking about how you're presenting your work and your process. And also this thing that we call 3D digital literacy and design skills. So this is what we mean when we say 3D digital literacy and design skills. So this design and make innovation, spatial reasoning, and also trying out computational design in some way. You don't necessarily need to do that, but it will, increase your score when the judges are looking at your work. So this is the breakdown. So next I'm going to share just the story of Ajith's design. So Ajith lives in North Carolina, and he was inspired by every summer he and his family would travel to the coast, to the Outer Banks. And he would, even in his short life, he was only 15 when he designed this, he would notice year after year, it was one actually particular house that the water just kept encroaching closer and closer to it. And it made him worry that it's, within a few years, this house might wash away. So that was kind of his inspiration for designing this. It's meant to be transportable, modular, and also 3D printable house that's meant to be resilient to hurricanes and flooding. So this is the physical prototype that he created. So he 3D printed it. And he began with research. So he started to research different constraints for his project, from rising sea levels to, the patterns of hurricanes in the area, really thinking specific to the location that he was planning to build his house. He started with sketching. So this is a great question when Fope arrives that we can ask her about. So he started actually with sketching on paper with pencil, and then started to think about scale and dimensions and measurements. Then he brought it into Revit. And in Revit, he started to, get into more detail after he had his kind of concept together. He even started to think about the structural elements of his design and the way that they would withstand, hurricane weather. He also used Autodesk simulation technology in order to simulate real-world forces like wind, for example, in this image. And he also really cared about, and this is why he won the best physical prototype, was the constructability. Now, we've had students in the past that didn't use 3D printers and won the best physical prototype, and they, used craft materials and, wood and not necessarily 3D printed things, which I think Michael might have some stories about that as well, who's going to be sharing later. But he 3D printed his. He went through the process of how he made it look really beautiful in the assembly, and he included really beautiful images of his design. He also tested it. So he took his 3D print and brought it out to an area with water and kind of played around with it to see how it performed in that environment. So you can actually, I think that one great way to kind of get ready for the contest or to kind of start spinning your wheels in terms of what your design might be is to kind of look back at and reflect on, previous winners' entries and to kind of start to think about what are some, ways that the student is using an engineering mindset or really showing their process or really kind of telling the story of their design. So any questions from here, Paulette?
Oh, actually, and Fope is on. So if you want to go back and ask that question, we
Fope,
don't have any new ones, but I can repeat that one for her.
Yeah, so Fope, the question was, if a student hand draws a design, what is there a way to bring it into AutoCAD or into Revit?
Good question. We do not currently have that capability now, but to the best of my knowledge, but I'm not on the product team, so I can always connect with them and ask if we have that. Maybe that's a new feature that was released recently, but that would be really cool if we
It
could
would be
do it.
really cool.
Yes.
So I'll say as an architect as well, you know, that there's a couple methods of getting closer to what you're looking for. You might have to go through a few different programs to accomplish it, but the most simple one would most likely be taking a photo of your sketch and throwing that into an Autodesk program, could be, you know, as an image or PDF, making sure that it's scaled correctly as well, right? So like maybe put a ruler in the photo up to something that you know that defined distance, and then you can scale it in the program and use that as a reference to get started.
That's really great advice, Jack. Thank you. All right, so Fope is actually going to present in a minute. I just wanted to share with you, just in like 5 minutes, just a quick demonstration, beginning with how you can use the starter model. So we have a starter model that was provided by Factory OS so that students can kind of think about their design process. You don't have to use the starter model, but again, if you're having trouble getting started, it's a great starting point. So this is where you find it. It's on the contest page, and it'll bring you into Tinkercad, and you'll copy and tinker. And then once you're in Tinkercad, and I think I'm going to switch to perspective view, so you can see all the different modules. So we have some exterior and some interior. So I'm just kind of play around. I'm deleting some of the trees that are there. Just using my arrows keys to move it around. We do have we have align tools within Tinkercad, but I was just kind of quickly playing around. So I was aligning it by eye. So that's one of the interior modules. And then from here, I wanted to just start to think about, you know, so I'm using the rotate tool to rotate it. These are just getting in the way. And then you're zooming in using your camera controls and just starting to, I use the duplicate tool to duplicate, and then grabbing a tree, and then just again using its Command D to duplicate. And then, you know, just like very quickly, you can just start to iterate and create design. And, you know, you might want to continue in Tinkercad. You might want to move into a different program. You could move, I'll actually show you in a little bit, you could move your design into other more professional tools. But one new feature within Tinkercad that I wanted to share with you that I think would be beneficial to your architectural designs is we now have sketching within Tinkercad. So you can quickly go in and make kind of a vector line drawing. There's Bezier curves as well. You can edit it within Sketch. So, and then I'm just like, I like the shape that I made and I'm just duplicating it. I'm using the Smart Duplicate feature. And then I'm just, you know, pushing up the handle in order to extrude. And then you can actually sketch on the design that you've made. So I am making kind of a Bezier curve at the top. I didn't like it, so I edited it a little bit. And then I can turn that shape into a hole, and I can combine those shapes. And then I have kind of like an interesting shape to play around with. You know, you can change the color, you know, you can change the transparency, and there it is. So just like fun, quick tool to kind of play around with. And then from here, I wanted to show you just quickly how you could take your design and then put it into Forma, which is a conceptual architectural tool and platform within Autodesk. And I'm going to show you what you can do with it. So you can really think about like placemaking in specific locations. So I'm just typing in the address of our Autodesk office in Boston. It's in the seaport in Boston, so you'll see the ocean. So I'm confirming my map area. And then you can add, and it's free, it says add, and like when your educational version, I think the only thing you see is free. You can add data like buildings and roads to your map in order to populate it with real life 3D context. I'm looking at this and I'm like, I want to see the ocean. So I'm going to go in and actually add satellite imagery as well. So here we are, and we have kind of a canvas to design on. So now that I'm here, I need to just kind of draw out the limits of my site. And that's important to you for using the analysis tools within Forma. So here is my site. and the boundaries. And now I'm going to go into my hub, and I have my design that I made in Tinkercad, and I'm going to move it onto this site. You can do things to your design like rotate it. And I want to rotate it because I'm putting it in this parking lot where I usually park. And I want it to sort of line up with this like little park here. So you can move it around and rotate it. And here next, I'm going to then, just within my limit, the limit of my site, I'm going to do a sun hours analysis. And then I'm also going to do a daylight potential analysis. And then I'm going to bring it into this screen where you can compare the two images. So on the left is my sunlight analysis, and on the right is the daylight potential. And then from here, I can actually also add inspection points. And it's cool that they kind of pop up, in both panels. And you can take a picture of it. And maybe that's something that you use in your entry for the contest, that you've done an analysis of your design using Forma in a specific location. So that's all I've got from my demonstration. Any questions before we move on to Fope's presentation?
Nope, nothing new.
All right, Fope, you're up.
Thank you.
I'm very excited about your presentation.
Thanks, Kellyanne. Hello, everyone. My name is Hope Bademasi, a construction researcher with Autodesk Research. My background is in construction management. I've been at Autodesk for a couple of years, 3 years, going on 4 years now. And before then, I used to be a professor of construction management. So happy to be here with you today. And I will just quickly talk to you about how innovative builders are developing creative solutions to make housing more accessible, more sustainable, and affordable for everyone. But let's start with understanding the problem, right? So Kellyanne has presented the challenge for this year. What we're seeing today in this day and age is that housing costs have skyrocketed, but not a lot of people's income has increased to match the pace at which housing is getting more expensive. And statistics show that nearly half of all renters spend more than 30% of their income on housing. And nationwide, we're short about 7 million affordable units. So there's the affordable housing crisis, not just in the US, but it's, almost worldwide crisis situation. And this is as a result of multiple factors. There is the rising land and construction costs. We have policies and regulatory barriers. We have a shortage of skilled labor as well in construction. We have outdated building models and methods. And of course, we have the climate crisis. So we're seeing a lot of researchers and practitioners gathering together and joining forces to create effective solutions to address some of these challenges at the same time. So the first, I think
You covered
I just covered this.
But it's a nice visual, Fope.
The first method of innovation that I would share, we can skip this one. It's just for information. We're seeing this is not very new. It's been around for a couple of years, but it's starting to become more popular. So the Factory OS project that Kellyanne shared, for example, is an instance of this where we have modern methods of construction. So we're seeing modular and prefabricated houses. That's where we go into an offsite factory and assemble these houses. So this is borrowed from the automotive or manufacturing industry. So think about how you would make cars. So we go into factories and we make buildings, and then we move these buildings to site and assemble them on site. So we're seeing that this type of method reduces construction time by up to 50% and lowers cost of construction. So this is an example of that. And then also we have 3D printing for homes, and I'll share the case study later on. But we're starting to see 3D printed houses where homes are built within 24 to 48 hours also. And then another area of innovation that we're seeing is in material science innovation, right? So we're starting to move away from typical construction methods that either contribute a lot of carbon to the environment. So think about cement and concrete, or there's just a long lead time. So that means there's a supply chain issue. Either we have to import them or they take a long time to be processed. So we're starting to think about what are new materials that we can introduce in construction that would make housing more affordable, as well as make construction time a lot quicker. So there is cross-laminated timber that we're seeing, which offers greater strength than concrete, but it's lighter and more sustainable. We're also seeing recycled and bio-based materials that, create new possibilities of materials from waste. So we're seeing new potential in waste streams. We're also seeing carbon negative materials like mycelium based. So that's the Futures project again, uses mycelium facades, so for the exterior of the building, and things like greener concrete or greener cement used also. But the idea here is to reduce both construction costs, but the long-term energy costs as well, so that utilities are not as expensive for the homeowners. So it's not just about environmental wins. Again, affordability is at the forefront here, while we're not sacrificing efficiency and durability. And then we're also seeing innovation with how we use spaces or how we interact with spaces or construction sites. There's a lot of new technology being implemented to help with, and I mentioned the shortage of skilled labor, so to help with completing tasks on site. So things like visualizing the building in virtual reality, and also, being able to identify construction errors before they pop up on site, so that we can, not delay the time for construction any further. We're seeing the use of digital twins also. BIM, you might be familiar with already, but using Forma, using Revit, Tinkercad, and all of that, they're helping to reduce rework on sites, and also they're helping to reduce life cycle costs, reducing errors, all of which, contribute to the cost of construction sites. So we're seeing digital transformation. We're seeing a lot being done with data. So this is where AI comes into play. A lot of data is being collected on construction sites. So how do we start to use that to be able to make predictive analytics for how to make the schedule shorter, so optimize schedule, for example, to speed up construction, optimize the budgets, the design for the budget, so that cost isn't an issue also. Next slide. So key popular case studies I want to highlight that could be inspiration for you all. We have the Icon 3D printed homes. These are communities in places like Austin, Texas, and New Mexico, and also in Mexico, the country too. But we're having 3D printed homes by Icon, where they come in and build these homes, and they're usually done within 2 to 3 days. So it's pretty quick, very aesthetic. You can see it looks nice, but also efficient with energy efficiency, again, to make sure that the cost of utilities are down for the homeowners on a longer term. We have the Factory OS project in West Oakland. It's a 300 units affordable housing that's currently being developed. Also to note that the cost of the 3D printed homes in Austin, they have stated that it's 50% below the regular market rate for typical construction houses. So I thought that was an interesting fact. If we can 3D print at a very shorter rate, that's with the time, and then it's still gonna come 50% below, so half the cost of typical construction. And then the Factory OS 300 units affordable housing in West Oakland, currently being built right now. This was modular construction, so built in a factory, assembled on site. They used tools like Forma to be able to calculate, the carbon, the cost, daylight, things that would affect utilities. And, they're able to see all that trade-offs very early on from the conceptual design phase. So that's like the stage after your napkin sketch, where you have your sketch in a mass form, and you're able to start to do all those calculations very early on. So with all the technology that they implemented, the cost of construction was reduced by 30%. And then I also wanted to highlight this first CR2 CLT, cross-laminated timber housing. It was the first of its kind in mid-rise. So first of its kind in Seattle. And we can see there as well, because they use CLT. So with CLT, it's faster. There's methods for, joining the structures, so the beam, the columns, that helps to reduce construction time. Also with the way the material is processed or developed, there's not a long lead time for that. So yeah, these are all public case studies that you can look up. There's information about the construction methods, the benefits from using these types of methods, and I thought that would be good to highlight. So what does the future of affordable housing look like? We're seeing how technology are changing the way we build things. And I wanted to highlight some that I think we are starting to see. So they are emerging, and I expect that they might become common practice within the next couple of years. But the first one is AI designed neighborhoods, where we're using artificial intelligence and generative design to optimize community layouts, but also thinking about human-centered design, right? We're thinking about the residents' well-being, how they are connected to infrastructure and they have access to things that will make life better for them, right? So it's not just about the singular home, it's looking at the community at large, and access to transportation, to other social amenities that they may need, right? So we're able to start to optimize design at a larger scale, or the neighborhood scale, as opposed to just the singular family housing scale. And then you can start to do things like that in format as Kellyanne showed you. You're able to put in the address and see the larger scale of the site that you're working with, and start to plan and optimize design around the existing environment. And the next one is biophilic design, which incorporates natural elements. So we're starting to design together with nature. We're starting to also mimic nature in buildings and design and landscape architecture and how the environment looks like. And all of this is really to improve the health and well-being of the occupants, right? Those are the people we're designing for on the long run. So it's beyond just providing them a place to stay, but also how do they perform in that space. Think about their health, mental well-being, and you think about how satisfying. Maybe satisfaction is not usually an outcome people think about when we're designing, but it's a service that you're providing, so you have to think about the satisfaction as well of the occupants within that space. And the next one I wanted to share, which is also a huge part of my research at Autodesk, is the use of existing materials that are already in the built environment. So circular economy materials is really about not using new materials as best as you can, because all of that contributes to carbon emissions. So with circular materials, we can reduce life cycle costs by up to 40%. Through reuse and recycling. So there's a quote that says the greenest or the most sustainable building is one that already exists. And a lot of these materials or components in existing buildings, they are usually demolished and just thrown away in the landfill, and they still have a lot of use left in them, right? If we look at their life cycles, some of them can last 50, 100 years. So how do we harvest those materials and reuse them in new construction or renovation or retrofit projects? So that is starting to ramp up in other countries, and also in the US, we're starting to see that emerge as well. And the last one I'm going to share is self-healing infrastructure, which extends the building lifespan when we think about materials that repair themselves. We're already starting to see research done with self-healing concrete, so that with bridges and roads and also in buildings, if there's a crack that's going to form, the concrete is able to, it looks very sci-fi, but like the material is able to, repair itself, so the cracks are filled before they can cause any damage. So this is part of material science and things that we're starting to see pop up. But overall, these new innovations address both, upfront affordability, is what we're starting to see, like cost is being slashed by 30 to 50%, but also on the long term, with having more energy efficient and carbon efficient buildings, we're seeing also long-term affordability and sustainability as utilities, become lower, and also the effect on the climate is also reduced. Yeah, so those are the innovations or things that we're seeing as being innovative. So how can you contribute? How can you get involved? Of course, there's several education paths that you can choose in architecture, engineering, in planning, or even in material science. There's different pathways, and also construction trades as well that can lead to careers in affordable housing. And of course, you can start getting engaged through your local communities and volunteer opportunities, and seeing how you can start to improve the local community, or contribute to the improvement of local community. Of course, we're here talking about the Make It Real competition. So that's another way to get involved, through projects, competitions, innovation labs around that address topics like this. So local housing needs and so on is also a good way to get involved. So I think that's it for me. Looking forward to seeing all the work everyone is going to do. If you're interested, I really encourage. They're always fun, I think, projects to get involved with. And yeah, I would open the floor for questions.
Thank you, Professor Fope. I was taking notes. This is good. Like if you're a student, like you want to start with research, and it's like you've already provided all these, different outlets for research and ideas to think about more deeply. So thank you, Fope. So did we have any questions for Dr. Fope?
Nope, there was just someone mentioned Roman concrete, and that was it for that. So I know there are very exciting things about Roman concrete.
Well, I love that you're sharing ideas with each other in the chat as well. So thank you so much, Fope. We're going to move next to our judge spotlight, and our spotlight is on Michael Hidalgo. So I want to just pass the mic to him to take it away and kind of lead us into the evening. Oh, before we do that, I just wanted to share with you, Fope is one of the judges for the competition as well. So Michael is a judge. We have judges from the Design and Make Ambassador community, but also within Autodesk, Josh Dobbs is judging as well. Danison Tavares, who is the executive director for the Boston Society for Architecture, is one of our judges. Ben White, who's was the director of the Builders Lab at Turner Labs at Berkeley, but he actually just took a really cool job working on housing policy for the city of San Francisco. So awesome judges, including Michael. So I'm going to pass the mic to Michael now. Take it away.
Hi everyone, thank you for joining us this evening. My name is Michael. I'm an Autodesk Design and Make Ambassador, as Kellyanne mentioned earlier, and one of your judges. I'll talk a bit more about the Ambassador program later, but more on me. I'm a civil engineering sophomore at Duke University, and I entered the Make It Real contest in 2022. Back then it was the Make It Modular contest was the theme. We tackled some of the topics that Fope actually mentioned in her presentation. I incorporated a green roof, as you could see on that rendering I included in my submission. Additionally, I tried to make it modular. That was actually the whole intent of the contest that year. So I designed for deconstruction and tried to source materials that were from buildings that weren't used or from secondhand sources. So that was a big thing I did, and I'm really glad it was brought up today in this talk. Additionally, I used Revit and Fusion 360 for my project. I just thought I was a motorcycle, if you guys read that. I used Revit and Fusion 360, which for me at the time was really scary because I did not know how to use Fusion 360 at all. And for Revit, I had used it in one of my classes in high school, but it wasn't a great introduction. into Revit, especially when looking at this. This is a container house, so I had no idea how to create those corrugations on Revit or pretty much anything. I only knew how to make like a house with four walls, plop in a basic family of windows, and call it a day. So it took a huge learning curve, which I'll talk a bit more through in the next slide. Killian, if you could please. So the first thing I did when taking this into account, knowing that I didn't know the software, is the first thing I did is I tried to avoid it as much as possible. Realized probably Revit was the best thing for me because I wanted really good renters. Although it seems, as Kellyanne has mentioned, there are a ton of other great software that Autodesk has software like Format. I wish I would have known about Format at the time. Like the analyses that you could do there are quite incredible. But that was the first thing I did. Like, I started my entry really early on. So I think right when the contest started, right when Ace started sending emails around February, I started going on YouTube. I looked at what other people did, similar to what I wanted to do. And I started learning the software, watching tutorials on how to create a shipping container. So you don't necessarily have to reinvent the wheel when you're working on your project. Someone might have already done what you're trying to do, and that's totally fine. You don't have to create something entirely new. You could source ideas from other people, make sure you cite them, and then adapt those things and make it your own. I think that's the first thing you should do and ensure you really start early. And I would also say the next thing would be to ask for help. I was very stubborn in this regard. So it was brought up earlier that I did not 3D print my model. I struggled very much to create that model with foam board, cardstock that I scored to create all the corrugations and all of that because I didn't have a 3D printer, which looking back, I'm really glad I did it the way I did. But with a 3D printer, I could have created some furniture on the inside, which would have been really nice, especially since I had already modeled it all in Fusion. That would have been a pretty easy addition. But I was a bit scared to ask my mentors at my high school to use the 3D printers, which we had a whole wall of. So reflecting back, that was not the best decision. I should have really just asked. And also for Revit, they would have been more than happy to help me with my Revit questions when I had them. So go ahead and ask questions if you have any to your ACE mentors, to professors, to teachers at your school, or even to Kellyanne if you have questions about your submission, or even me. I'd be more than happy to help to the best of my ability. And once you start thinking about all those things, it'll be so many things. You'll want to make your model on Forma, Revit, or Inventor, sorry, on Tinkercad, whatever you want the best to be. So you could get caught up on that, but you need to keep a holistic approach, like the grand scheme of things. You want to make sure that you do leave time at the end to do nice quality renders. And once you do those renders, I know a challenge that I faced many times was I was doing this on Revit on a virtual machine on a Mac because Revit's not natively available. So sometimes I encountered crashes, which were very heartbreaking when the low light renders would take about like 8 hours. So that was unfortunate. Or sometimes I would do an 8 hour render and then realize, oh wait, there's a mistake in my model, and I would have to go back and fix that. So you would really want to take into account all of that when you're time managing. And additionally, you want to create some statistics. Like in my project, I personally did a lead scorecard. I tried to do an estimate. I tried to do like electrical plans of the calculations because I was bringing it to my project at the time. And as Kellyanne said, you could do, I think she showed a project that had wind loading in Forma. That is like an incredible thing that might be relevant to your project, or something similar. I think would be a great addition to the project. Because as a judge, what I'm looking for is that you have a holistic application that isn't a holistic project that isn't just working within a vacuum. It actually serves a purpose, that it's well thought out, that it's feasible, it can be done. I think that's what I'm looking for the most in an entry. And even if you're not able to do that because of some constraints like your knowledge or the software, that you could write about that within your instructables. That is something I did. Think I said, oh, I think I should have done this, but my bad, I messed up on Revit and I didn't have time. But I think that is something also to include in your entry. Could you move on to the next slide?
Yes, that was great advice, Michael.
So next up, I want to share a bit about the Autodesk Design and Make Ambassador, which I am actually one of the founding members of. It's a really great program. Going back to Instructables, there's a ton of contests. You already get rewarded if you do win, but as an ambassador, you're actually incentivized to join those contests. So Grace, one of our leaders, she's always saying, oh, join this contest, you might get this many points, and those points might be redeemable for things like pencils, gift cards, a 3D printer, AirPods, all sorts of things. Additionally, it connects you to students from all over the country, people within Autodesk. We've also had a speaker from Ford. We've had TikTok, famous people speak to us. So it's just a really great way to get connected with people from all over, and it really pushes you to expand outside of your comfort zone. And it's also great for collaboration as you meet those individuals. There's a link a QR code down there that will take you to Instructables and the site to apply. Unfortunately, at this point, you have to be 18 years old and a university student. So I think a lot of you might not be eligible at this moment, but in the future, I think you should all definitely consider it.
Thank you, Michael. That was my question, was you have to be a college student in order to join, but it's something to think about in the future.
Yes. Sorry, that was one of my top points and I almost forgot.
Well, you made you sound really cool, Michael, so thank you.
I should have prefaced it with that first, but at least I got everyone to listen.
Yes.
So here on the left screen, on the left picture, that is actually at Duke University. That is a project I did in my Civil Engineering 132 class. That's the intro class. So we had to design a water Rube Goldberg machine. And the idea behind having these pictures here is that I want you to get an idea of what might come in the future if you do pursue a career in architecture, engineering, or construction. So we do all these sorts of cool project-based learning activities. So the idea there was to highlight all of the sources of energy. So how the water starts with potential energy, then it becomes kinetic, and the flow of the water being laminar, turbulent, and buoyancy because we had an object floating in there. Then pivoting to the right, that is a project I'm working on right now. We're designing a suspended footbridge that will be approximately 128 meters long, and we're traveling this summer to Eswatini, so a country in the southern part of Africa. And we're actually going to construct it, me along with 13 other Duke students and the local community there. So it's a great project that we're actually designing on AutoCAD. So it just shows all the things you could do with AutoCAD, even though how basic it is. Yeah, perfect. On the left side is a project I'm actually presenting on Saturday. That is a site survey somewhere in Ohio. I was just given a bunch of random points with northing, eastings, and elevations. And using, again, an Autodesk software, Civil 3D, I was able to plot all those points to create a topographic survey as seen there for the ASE conference. It's a challenge we're doing, and this Saturday I'm going to present it. Very excited to do that. And on the right, that's another crazy project we do in my C132 class. The idea behind it is that there's a zombie apocalypse, and we're trying to create a face mask to save us from particulate matter. So we took it to an engineering lab and we had it tested. If you're looking at it funny, it's because it's a ski mask with a diaper inside. The efficacy was not great. It was only about 25 or 26% effective. So I would not recommend that if you have a similar assignment.
Well, Michael, you've made college look really cool. I kind of want to go back now. You've made the Design and Make Ambassadors program very cool. I don't know about the eyebrows on the mannequin, but I think that
I think if we removed the mask, someone else drew a mustache.
Oh no.
Or a beard. It was a beard.
Well, this is amazing, Michael. Thank you. Does anyone have, so Michael is a judge. Before we sign off for the evening, do we have any questions for Michael, who's a judge, or even for me, or for any of the ACE friends that are on the call?
The only question that came in was how many applicants do you guys usually get every year for the contest?
It's over 100 every year. We normally, like last year, I think we got like 120 or so. It's usually like the number is somewhere in like the 120 or so, 130, I think, make it bridge. So yeah, over 100 is a goal. and especially the high quality entries.
And then I just wanted to also what Michael was saying about make sure you ask your mentors, reach out to us. We want to hear from you all. We want to help you. So don't be afraid to do that. And I think that Michael hit that perfectly when he said that. As a high school student, you might not know that, but a couple of years later, this is your advice. Oh, wait, there's a couple of questions coming in. How do we access the Tinkercad Forma software you showed us?
So Tinkercad, you just go to tinkercad.com, and Tinkercad's free for everyone. So, educators or, even non-educators that are on the call, that's free for everyone. I'll try to put in the chat where you can go to get information about the professional tools. So I'll put that in now.
Then another question, would you like to see more practicality or imagination in the entries?
Michael, why don't you take that one on?
I love this question.
I personally think it's great to be very imaginative, but I would also like to see there be some thought behind it, like be practical. Like when I was in the architecture magnet in my high school, so a big portion of that was starting to learn the building codes and how things can or can't be done. That's not necessarily expected that you know every single building code or you're a professional engineer and know what kind of loading could be done. But I think having a realistic expectation is a bit important.
I think adding to that as well, that's a great point. With these competitions in school, it's great to be realistic, but this is also your time to, think out of the box and be imaginative. So explore, ask questions. I think to Michael and Paulette's point, being connected with a mentor, they might they might ask you the questions you might not even think to ask, right? So like thinking about the ambassador program, right? So the more people you talk to, the better and the better project you will have for it.
Great advice. And I love hearing from the architect and the engineer. Imagine, be realistic. These are the accomplishments we hear in the industry too.
Yeah, it might be different if you talk
Absolutely.
to a structural engineer. So
Yes. And there's a couple of questions regarding subscription. Do you need a license to use Tinkercad? And do you need do they need to get the software subscription on their own?
So for Tinkercad, you just sign up, register for an account, and it takes like a couple minutes. So Tinkercad is easy. And then for the other tools, I just put the link in the chat. For the other tools, if you're a student, so there's different ways. So for educators, I believe they could get a classroom license for up to 250 seats for whatever tool is that they're subscribing to. For students, it's a 1-year subscription that it's free and you just need to verify every year. Like, for example, my daughter is 16 and I helped her get her license for Revit, and I just took a picture of her report card and uploaded it, and that was like I think she had it within a few minutes. I don't know. I sometimes can take up to 24 hours for the verification process, but it's pretty easy. So yeah, for educators and students, you just have to re-verify every year. For schools have 3,000 seats and it's 3 years. So you could go that route too, is to ask your school to get, the institutional subscription. And then the school just has to do the verification, and then they administer the seats to the students and to the educators.
And then there's an architecture question. This might open up a whole nother webinar. Is it more logical to go to a 5-year school for architecture or a shorter 2-year school and get into the workforce faster? Jack and I have been talking a lot about this.
yes, yeah, and this is an ever-changing question as well, and I'll share my personal experience. So one, it depends on the jurisdiction that you're going for, your license, right? So like different states have different requirements. So in thinking about your career in architecture, first start where you might want to practice, right? So, and to Paulette's point, this could be a completely different webinar, but there's some great resources out there for that. Myself personally, I went through a 5-year accelerated program. So that essentially was a combination of a 4-year plus a 2-year master's squeezed into 5. So I saved myself a little bit of time, but 2-year programs to start like at a community college, for example, is an amazing experience and can plug into accredited programs as well. So from a cost perspective, it can also save you money. 2-year programs also might be more technically focused from the start because they, to your point, are aiming to get people out into the workforce sooner, but that might not meet all the requirements to be an architect. So I highly recommend start by going to, for example, the National Council of Architectural Registration Board. They have a state tool to learn some of those requirements and education requirements. So
Good advice, Jack. Thank you.
Yeah, you might
To
like that
add
one.
to, I always intended to go to a 4-year engineering program, but I did start off at a community college before transferring to Duke. So definitely agree with the cost saving aspect of that.
and I proudly actually teach at a community college as well. So I can attest to the quality of that education firsthand.
Well, that wraps up the questions in the chat.
Well, I think it's just every time we engage with students in this way, I'm always just blown away by how curious you are, like what great questions you ask, like how you contribute, to the conversation. So we are like, I can speak, I think, for all of us that like we're so excited to see what you imagine in thinking about affordable housing solutions that can solve other problems in communities as well. So thinking about the what you're designing, but also the surroundings and the spaces around it. So kind of bringing it back to that question from the beginning and really kind of making it feel like home for your intended residents. So we're super excited, super grateful to Michael for joining us, our ACE alum, who is now going on to big engineering places and is at Duke now. And also thank you to Jack and to Paulette and to Fope. So we always love, connecting with our friends at the ACE Mentor Program and also bringing in new students to the ACE program because it's a wonderful, wonderful network to be part of. So thank you for joining us, and we hope to see your ideas. So
And
have
thank
a good
you, Kellyanne. Thank you so
Oh,
much for all that you do as well. We appreciate you very much.
right back at you, Paulette. All right, take care, everyone. Have a great evening.